Hi everybody, welcome to another video in Trigonometry, section 9.1, section 9.2, polar coordinates and polar equation. So up to this point, while we have the rectangular coordinates or Cartesian coordinates, x and y. Of course, from x and y we get r. But this time, to identify the point in two-dimensional space or to identify a point on the plane, instead of using x and y, we could use different things. By the way, I did mention two-dimensional plane, two-dimensional space, right? Meaning that it has two components. So earlier, if we have the component, here we can write that as x and y. So we can identify the point in any point on the plane as x and y. Now, another way to do that is, if we have a point x and y, we can determine the distance to the origin and the angle from the positive x-axis. So, to identify the point on the plane, we can give the radius and the angle. So in that case, we can find the point as well. So that's what we call the polar coordinate system. So polar coordinate system, first we have the polar axis, and of course this is the polar axis. To say it is array, so it's only go one side. This is positive side, this is the other side is negative. So this is array, and then of course we can rotate that ray, but the end of the ray is the point or the origin. Now, a point P is determined by the radius r. So the radius r on the polar axis, and then we rotate an angle theta about, rotate that from the polar rate. So in that case, we have the point. So pretty much the point now we determine by two components, because it is two-dimensional space. We need two components. If it is not x, y, we can use r and theta. Now, if r is positive, the way we define that, it will be on the same terminal ray. If it is negative, it will be on the opposite. So if it is negative r and theta, if it is negative, it will be on the opposite as that direction. And when r equal to 0, we are at the pole. Now, we did have this way back in chapter 1. If we have an angle like that, we can go extra revolution and get back to the same thing, in which case we call coterminal angles. So the radius will be 1. The angle, we might have a bunch of different representation. We might have extra revolution or add or subtract. So in that case, we can write with the radius, with r, the distance to the origin, and then we can write like this, which means coterminal to coterminal angle of theta, and then negative r if we go in the opposite direction, and then we go on extra half revolution, we still get back to it. So if we want to go to opposite direction, which is fine, but then we have to go a half revolution to go get back to it, which is fine. So that is a different representation. One way is we keep the r and we get the coterminal angle. Another one is we negate the distance, but we have to add half a revolution to turn it around. Right, let's look at the first example here. Find two more representation, one with positive radius and one with negative radius. So we have this. If we want to have the same point, the same representation, if we want the radius to be positive, so we're going to have 2. Then we can just add 2 pi to it. do that, give us the coterminal angle, which is represent the same point. 2 plus 1/3 is 7/3. So convert that to fraction. 7/3. Right, so that is 1. Now, if we want the one with the negative radius or negative r, so we're going to negate that. But when we negate r, we have to add a pi to it. So we turn around and get back to that same point. Right. Of course, I can always add 2 pi to it or subtract 2 pi to it, or do that to get coterminal angle of this. But here we just say it's going to be -2 and pi 4 pi over 3. Right. So we have the same point on the plane. We have infinitely many representation in polar form. So in polar form, we might have a lot of infinitely many representation in the in polar coordinates, because we have infinitely many ways to represent an angle as coterminal angles which represent the same point. Right. Now, most important in these two sections is can we convert an equation or a point from polar to rectangular and from rectangular to polar. So it'll be simple enough, which is basic trigonometry. Right. So we have the point x and y. So if that is x and y, so this will be x and this will be y. Yeah. I could say x is the distance here and y distance there. Now, we can just write trigonometry for that angle. So we'll say sine is opposite over hypotenuse. So multiply the r over, we have y equal to r sine theta. Right, and then next cosine is x over r. So x is equal to r cosine theta. So that's simple enough. Like I said, basic trigonometry. So if we have the point x and y will be equal to r cosine theta and r sine theta, so the relation is pretty simple. Now, of course, r is equal to x squared plus y squared. So r equal to square root of x squared plus y squared. That's easy. And tangent is y over x. So that is the definition of trigonometry. Trigonometric function tangent is y over x. And because this is true, because x squared plus y squared equal to r squared, r by default we should choose that to be positive. So pretty straightforward, right? Right. So let's look at some examples. Convert the following points from polar to rectangular. So we go from polar to rectangular. Polar meaning that we have r and theta. Rectangular meaning we're going to go to x and y. So in this problem we are given in polar form, so r and theta. Of course it could be in degrees, could be in radian, but x is equal to r cosine theta. So it's going to be 2 cosine of negative 30 degrees and y equal to r sine theta, 2 sine of negative 30 degrees. cosine is an even function, so this will be just 2 cosine of 30 degrees. Cosine of 30 degrees is going to be 2 square root of 3 over 2. And sine is an odd function, so sine of a negative is a negative sign. And sine of 30 degrees is 1/2. So cancel the 2, we have square root of 3, and we have 1. So the point here in rectangular coordinate is square root of 3 for x and 1 for y. Of course, I forgot the negative, did I? Right. So let's check. We have 2, so the radius is 2, and the radius is negative 30 degrees. So negative 30 degrees here, and then 2. The point we have is square root of 3 and negative 1. Yeah, so that look right, right? Square of 3, negative 1. So that negative 30 degrees. Radius is 2, so we just that. Next, we have here, which is r is negative 4 and theta is pi over 3. So same thing. If we have r and theta, x is r cosine theta, y is r sine theta. R is negative 4. By default, we choose positive, but it could be negative too. And then cosine pi over 3. Cosine pi over 3 is 1/2. So that gives us negative 2. And then the sine pi over 3. Pi over 3, sine pi over 3 is square 3 over 2. So we get negative 2 square root of 3. So if we want to check, we go negative 4. So how did that work? The angle is pi over 3, so pi over 3 is here. But instead of go positive, will be in that direction, we go opposite. So negative 4 will be here. And we have x negative 2 and negative 2 square of 3. So that's about right. So very straightforward. Knowing r and theta, we can find x and y directly. Now we do the opposite direction where we go from rectangular to polar. Now this time we have x and y. Rectangular meaning that is going to be x and y coordinates. To polar meaning r and theta. So pretty much we're going to find r and theta for that. Now this might be a little problem because for x, y there's only one representation for x and y. But in polar coordinate there are infinitely many ways to represent it. And even then there will be something that we have to pay attention to. So here we'll put the asterisk here because there are quite a few things to note. First, we cannot divide by 0. So if it is the case, yeah, that might be a problem. But that is not what I put the asterisk for. That might be for something else too. So always at the end we draw it and check to see if it works on both rectangular and polar. Right, now we have x is 2 and y is square root of 3. So let's just say if we want to, x is 2, y square of 3. And then we can solve for r, x squared plus y squared is r squared. So that's not difficult. By default, we can just say, yeah, let r be positive. So 2 square plus square root of 3 square. By the way, I think this is a typo. Let's please change that to 1. Yeah, because with that case, the math will come out nice and even. 1 square root of 3 squared 3, so square root of 4, which is 2. Right. So, and how do we get to theta? So we have R. Good. Now, tangent of theta is y over x. I did not say that theta is tangent inverse, but we say tangent of theta is y over x. In this case, we have y over x. So we can solve for theta, which is tangent inverse. Of course, in trigonometric function, we may have tangent inverse and then plus pi r, because the periods of tangent is a pi. So we might add a pi to it or subtract a pi from it. But here, if we use the calculator to find the inverse, make sure it's in the degree mode. That's 60 degrees, which is square root of 3. I mean pi over 3. Now let's check to see if it is true. X equal to 1, y equal to square root of 3 is about 1.7. And so we talk about this point, which is about 2, and the angle is pi over 3. So that's look right. So yeah, that's what we have. So we write the point as r equal to 2, theta is pi over 3. Next, I will have x equal to -3 and y equal to -3. Right, still the same. R equal to x square root of x squared plus y squared. So we have square root of -3 squared plus -3 squared. That's square root of 18, or square root of 9 times square root of 2, because 18 is 9 times 2, or 3 square root of 2. All right, we have the radius, we have r. I think it should, or sometimes called a modulo, but it's fine. Now the tangent, to find the theta, tangent theta is equal to y by x. Y over x, which is 1. So tangent is 1. We can get back to theta, which is tangent inverse of 1. Which is 45 degrees, pi over 4. Now let's check. -12 -12, so it is here. However, we have the angle pi over 4, so it is not true, right? What had pi over 4 here is here. Now, remember, when we solve for tangent, it could be tangent inverse plus k pi. So if it is not right, we can always add a period, which is a pi to it. So we add a pi to it, so it will get into the right quadrant. So that gives us 5 pi over 4. Yeah. So we say the radius r is 3 square root of 2, and the angle is 5 pi over 4. So we have r and theta. So the asterisk I want to write here is make sure that check the quadrant. Make sure whatever we have when we solve for theta is in the correct quadrant. If it's not correct, add a pi to it to go to the correct quadrant. Right, so we can change from rectangular coordinate to polar coordinate. We have those 4 formulas: x equal to r cosine theta, y equal to r sine theta, and then r is equal to square of x squared plus y squared, or x squared plus y squared equal to r squared, and tangent is y over x. Right. Now that's the first part of the section. The second part of the section is we still convert between rectangular and polar. However, now we convert to the whole equation. Right. So once again, this will be given in polar. So we have r and theta. We convert that into x and y. So it's not that bad with the formula, right? R equal to square root of x squared plus y squared, which is r. So we have square root of x squared plus y squared equal to 3. Square both sides. We have x squared plus y squared equal to 9. And then next, r equal to cosecant of theta. Or cosecant is 1 over sine, right? And then we can do the cross multiply. R sine theta equal to 1. So r sine theta is y, right? R times sine is y. So if y equal to 1. So that equation is equivalent to the horizontal line y equal to 1. Nice enough. So we use pretty much 4 formulas and try to write this in terms of x and y, because we want that to be in rectangular form. Right, next, theta equal to pi over 4. If we have theta, the only formula that have theta is tangent of theta is y over x. So we take tangent on both sides. So tangent of pi over 4 is 1. We did that earlier. So we have tangent of y is 1. Tangent of theta is 1. And tangent is y over x. So if y over x is 1, cross multiply. So if y is equal to x. So from that polar form, we can convert to rectangular form. If there's theta by itself, take tangent, because tangent is equal to y over x, and then we convert tangent equal to y over x nicely. Right, next, if we have r equal to 2 cosine, the cosine by itself is not going to help. But if we have r times cosine, that's going to be x, right? So what we do here is, if we multiply an x to it, if I multiply an r to it, so I have r squared equal to 2r cosine theta. R cosine theta is x. So I substitute that in for x. And r squared is x squared plus y squared. So now we have the equation in terms of only x and y. That's exactly what we want. Yep. That is the formula we have. Right, so simple enough, right? We have r and theta. Now trying to write everything in terms of x and y. When we do that, we're good. Right, so that is where we go from polar to rectangular. Yeah. So if we have the theta by itself, try to get to tangent, because tangent is y over x. If we have the sine or cosine by itself, if we multiply by r, that gives us x and y. Now r squared is x squared plus y squared, so that also works. Next, convert an equation from rectangular to polar. So now what we have is rectangular, meaning we have x and y. Now we convert in terms of polar. That's actually even easier, because there are only two formulas. X is equal to r cosine and y equal to r sine theta. Right, y equal to 2. Y is equal to r sine theta, right? So we start with that. And if we want to, we can just stop right there. We have r and theta in the equation, which is good. However, I just want to say r equal to something. That would be better, right? So divide by the sine 2, sine theta. And divide by sine is cosecant, so we say r equal to 2 cosecant theta. Right. So we have x and y, trying to write that in terms of r. Now x squared plus y squared equal to 25. X squared plus y squared is r squared. And yeah, straightforward, right? Of course, we can put r cosine, r cosine, r sine here if we want to. So x squared is r cosine for x, we square that, and y is r sine theta. Now we square that, give us r squared cosine squared plus r squared sine squared. R squared factor out, cosine squared plus sine squared. Cosine squared plus sine squared is 1, right? So we have r squared equal to 25. Of course, even better, if you can take the square root, we can just say r is equal to 5. That also works. Right. Next, y equal to x squared. Now, not much we can do here. Y is r sine theta. And x squared is r cosine. And then we square. Square both sides. Square here. We have r squared cosine square. Not much we can do here, except I can divide by r. R and r cancel out. So we have sine theta equal to r cosine square. If we want to, we can divide by cosine square on the other side. And that's what we have. But not much we can do. Like I said, when we have the equation that have r and theta in it, we're done. Next, 2x plus 3y equal to 5. Once again, x is r cosine theta. Y is 3r sine theta. I can just factor out the r. I have 2 cosine theta plus 3 sine theta equal to 5. And then divide by that, we have r by itself. Or we can just stop in that form, which is perfectly fine. Or divide by that over, which is also fine, which I will write like that. Right. Next, symmetry in polar coordinates. This is not the focus of the section, but if we have the symmetry, I'm just going to demonstrate real quick. if we have the point R and theta like that, the point symmetry with respect to the x-axis or the polar axis, this point is R and negative theta because this is positive and that is negative. Just straightforward. Next, symmetry with respect to the line y equal to pi over 2. So say we have the point here R and theta. Symmetry on the line y equal to the y-axis or the line theta equal to pi over 2. If this is the angle theta, this will be the supplement to it. And then we still have R. So this point symmetric with respect to line theta equal to pi over 2 is going to be negative R. Not negative R, I'm sorry, positive R. The same R, but the angle is pi minus theta. And then of course we have symmetric with respect to the origin, which is if we have the point there opposite to it, just say a negative R comma theta, or we have R but add a pi to it. Right, so we have those kind of symmetry. Now, if we want to graph it, which is perfectly fine, use a calculator. So when we graph, make sure it is in the radian mode. Right, that's the first thing. And then make sure that the graph is in polar mode. So radian and polar. Right, now let's graph. If R equal to 5, for example, but that is a circle, right? Yeah, make sure this is have the same x-axis as the y-axis, so we use square, so that is a circle, right? Now, of course, we can type a lot of things like 2 cosine theta. Right, this is the equation y equal to 2, right? So I would say, I'm glad to go back and catch that. This will be cosecant. So it'll be 2 divided by cosine of x, cosine of theta. Just hit that button. If it is in the polar mode, automatically it will give us the theta. So if it is rectangular, it will be x. Now you see the equation is this divided by sine, right? Yeah. So we have the equation y equal to 2, which is good, right? And R equal to 2 cosine theta. That is a circle. Let me zoom in. So that is a circle. Yeah. Of course, there's a lot of things we can graph. If you try something like 2 cosine of 5 theta, we have a flower of 5 petals. If sine, that also flower, but rotate a little bit. So of course, when we look at the graph, we can tell the symmetry as well. Right. So this section only involve about polar and rectangular coordinate. X equal to R cosine theta, Y equal to R sine theta, and then R is square root of x squared plus y squared tangent is equal to y over x. So we just have the relation between a rectangular and a polar coordinates, or rectangular and polar equation. So we just have those formulas that relate those points from polar to rectangular and from rectangular to polar. But that's all I want to cover in this section. As always, thank you for watching and see you in another video in trigonometry.